did we calculate the new height? What math did we do with our original height and the scale factor potion?
We multiplied our steady height times the potion scale
Yep.
factor.
And that's how you use a scale factor. You multiply it times your original value. So if you want to increase the size of something, you multiply times that number. If you want to decrease the size, you also multiply times that number. So which scale factors caused them to grow? What are the values of the scale factors that cause them to grow? I know you noticed this yesterday, Noah.
Can I say what I said yesterday?
Yeah.
The ones above 0.
Yeah. Above 1, right? So we had 3, 2.5, and 3 halves. And what do we notice? They are all values greater than 1. Right? So anytime you multiply greater than 1, that means you're increasing because you're multiplying it times more than 100% of that actual value. Go ahead and do the next one where you list the scale factors where people would shrink. So for number 3, it says list all the scale factors that caused Harold and his friends to shrink. What do you notice about those 3 scale factors? Do they have in common? They're all less than 1, right? They're between 0 and 1, right? So the values you should have written down would be 1/2, 1/8, and 0.4. And they are all values between 0 and 1. What if you drank a potion that had a scale factor of 1? What's going to happen?
You're going to grow.
Nothing, right? You're just going to stay your same size. Is that what you're going to say, Noah?
Yep.
Sure. Okay. So nothing. Nothing would happen. Size stays the same. Okay. So just out of curiosity, if you had to choose a potion, which one would you pick? Would you want one that makes you grow or one that makes you get Oh man. Okay, but does anybody else have thoughts on that? Let's pretend you're like full grown adult, like you are done growing just naturally. Would you choose one to make you grow or shrink?
Because if it makes your age go young.
If I'm like 6 foot, I would have to.
Depends on your age. You girls okay over there?
There's a bug.
The spider.
They're freaking out over a spider.
The spider?
We don't know where it lives.
She said she saw it. It's like,
I wouldn't know the difference because this one's
Okay. Okay, you'll be fine. All right, now we're going to apply the rules of scale factors to some shapes. If the scale factor is greater than 1, it will enlarge. If the scale factor is less than 1, it will reduce. A dilation is a transformation that either enlarges or reduces the size. To dilate, you multiply by the scale factor. So these are all the things we just talked about in our little Harold and his friends situation. How do I turn a fraction into a decimal value? What do you do? What math?
No, multiply 5.1.
So if I wanted to change 2/5 into a decimal, in my calculator, I would do 2 divided by 5. So you divide the numerator divided by the denominator. So 2/5 is actually equal to 0.4. So if we're going to reduce the size, right, because this is less than 1, we're going to multiply each of these values by 0.4. So get your calculator out and go ahead and figure out what would be the side lengths of this rectangle if we reduced it by a scale factor of 0.4.
Divide or multiply by
We multiply by 0.4. Are you guys going to open up your calculators and do the math? You're going to do the math? Do the math?
Quick math. What?
Get your calculators out. Hannah, open up your iPad. Get your calculator out. I want her to do the math. I want you to physically figure out the scale factors. Right? I need you to do this. It needs to become a memory that you experience. Nope, those are just the dimensions. So Mia, what did you get?
14.
I think it's supposed to be 14 and 6, right? For number 6, this is going to enlarge the figure because our scale factor is greater than 1. So go ahead and figure out what our new dimensions would be if our scale factor is 3.5. Jackson, take out your earbud, please. Thank you. Maggie, what'd you get?
I'm still working on it.
Okay. Carmen, what'd you get?
77 and 35.
Yep. Great. And then for this one, we have an improper fraction that's also going to give us a repeating decimal if we were to change it into a decimal. So when you have something like that, you multiply by the numerator, divide by the denominator, right? So 30 times 5 will give me 150. 150 divided by 3 is 50. $24 times 5, I don't have that memorized, hold on, is 120. And then 120 divided by 3 is 40. Now if you just put in your calculator 5 divided by 3 times 30, you would get the number as well, okay? And on your Desmos calculator, you can leave it as a fraction and then multiply times 30, and that would work as well. Okay, so how does everybody feel about multiplying to figure out new dimensions? Decent? All right, now we're going to work backwards. We have the dimensions. We need to figure out what the scale factor was. You okay?
Yeah.
You sure?
Yeah.
Okay. All right. So we're going to use a proportion. We're going to take your cross out where it says summarize today's lesson. We're going to use that as a work area. And we're going to use the new dimension over the original. New dimension over the original. Now, the catch is you have to use the same part of the figure, right? So if I'm going to use GH, I also have to use G prime and H prime. I can't mix match the parts of the figure. So I'm going to put G prime, H prime in my numerator because that's the new value. And then GH in my denominator. And I'm going to get 10 over 8. And what does that simplify to? 5/4. Yep. So that's my scale factor. Right? So I took the dimension of the new, divided it by the old, or original, and I got my scale factor. Let's do the same thing for these rectangles. Which side do we want to use? WX? And then we also have to use WX. How do I know what this dimension is, though?
8.
Because the other side is 8, right? And this is a 12. So I've got new over original. So I have W prime X prime over WX. Oops, that's supposed to be 12 over 8, not 8 over 12. No, wait, yeah, it is 8 over 12. What's going to be my scale factor? Which can be simplified even further.
2 over 3.
2/3. You feeling good about scale factors? Easy peasies? So easy, right, Jillian? Okay, woo! We made it. And this section up here is pretty easy. You're going to look at the scale factor, and you're going to tell me would it enlarge, reduce, or preserve the size. What does the scale factor have to be for it to preserve the size? 1. Okay, go ahead, fill it in. Okay, check your answers. How we do? Yeah? So we know what the shape should either get bigger or smaller based on the scale factors, right? Sure. Okay, let's do this bottom section here. We're going to use this rectangle. We know the dimensions. We're going to first dilate it when they give us a scale factor. And then these last two, we're going to figure out what was the scale factor if it was dilated. So remember, I'm going to multiply times the scale factor. So what decimal does this convert to? Mm-hmm.
2.25.
Yep, 2.25. And how did you find that, Maddie? 9 divided by 4. So then we're going to do 32 times 2.25. And we're going to do 8 times 2.25. Obviously, it's going to enlarge the value because this is greater than 1. Use your calculators. Carmen?
You can still just like do 32 times 7 divided by 8, right? Like for the next one. Well, like you could still do.
8 times 9 divided by 4, you mean?
Well,
Oh, are you talking about this one?
yeah.
Yeah, that's fine. Yep. Okay, so what do we get for number 10? What are the new dimensions? Jillian?
72 and 18.
Yep. Okay, how about number 11? The decimal value is 0.875, or like what Carmen said you could just multiply by the numerator, divide by the denominator. Obviously, this is going to be a reduction. Ben, what did you get for the new dimensions? Yep, do it, please. Thanks. All right, Ben? Yep. Thank you. All right, and then these last two, we're going to determine the scale factor. So I'm going to use the side that is the longest to compare to the side that is the longest. Remember, we do new over original. So this would be 24 over 32. We can tell by the numbers that it's a reduction. So what was it multiplied by? What was the scale factor? We need to simplify this number. Noah?
3/4.
3/4. Okay. Same thing for this one. We're going to dilate it. Obviously, this is going to be an enlargement because it increased. So my scale factor should be greater than 1. So there's a lot of things you can help yourself out with, like common sense, like yes, this number has to be greater than 1 because 80 is greater than 32. What'd you get? 2.5, which is the same as 5 over 2. Nice job. We did it. We finished the packet. No, keep it. I need you guys to keep it because we're gonna keep using it throughout the week for different things. Keep the packet.